Hello everyone, how you guys doing? I hope you're all doing amazing. Well, look at you. Aren't you looking fabulous? I think you've been hitting the gym lately. Good for you. So let's get started with today's problem, which is remove duplicates from a sorted array. In this problem, you are given an array nums, which is sorted in non-decreasing order, and you have to remove the duplicates in place and finally return a array which has non-unique elements in it that maintain their ordering, and at the same time, you have to remove the number of elements that are non-unique. So I think it's very similar to the last problem we solved in this series. And if you haven't watched that, I'll highly recommend to watch that before this problem because this is just exactly the same problem, just a minute difference from it, and we'll go through the difference during this video. And if you haven't watched it, we'll go through what we did in this video as well, so it's fine. So let's take up an example and go to our whiteboard, and we'll try to use the framework that we loosely defined in the previous video to how to solve these array problems. The one of thing in our tool bag that we already have to solve the problems that involve array in them. So let's get started with it. So let's take in this example. So you have nums, which is 0, 0, 1, 1, 1, 2, 2, 3, 3, 4, and you finally return 5, which is the number of unique elements in it. And also you update the nums array in place so that your non-duplicate elements are stored in the first 5 indexes. So yeah, I'm just gonna remember this nums array, and I started watching less reels than I used to watch when we made the previous video, so I think I should be able to remember them. So, as far as I can remember, it was 0, 0, 1, 1, 1, 2, 2, 3, 3, 4. Is that correct? It is correct. So, yeah, watching less reels actually improves your memory. A lesson for you guys out there. So, this is your array, and you finally want to return uh, k, which is your number of unique elements, which is 5 in this case, and also update the nums array in place so that you have 1, 2, 3, 4 in it, and you don't worry about the rest of the indexes. So if you've seen the previous video, it must be extremely similar to that. You can see that already, that the pattern is almost the same. The only difference is that in the previous video, you had to remove elements where you were already given a val, and you were basically comparing your elements in the array to that val and making the decision whether you want to remove that element or not. And we did that by using a third variable, which was a helper variable that helped us decide which index we want to fill the values in. So let's use that framework. First of all, we find our I, which is what values do we need to traverse through to solve this array problem. Now, in this case, again, I think we will have to traverse the whole array because we have to compare each value and see if it is not occurring twice in the array. And if it is, we'll want to remove it somehow. And the second part of the framework is to actually find our k, which is our helper variable, which will take care of which indexes of the nums array do we actually want to update. This is, I think, more specific to in-place operation type of array problems, but we get the understanding if you have watched the previous videos. Okay, so this is your k, helps in in-place problems. And in this case, as we want to return the final array, by updating the values in the first 5 indexes or the first non-duplicate length of indexes. So in that case, our k should start from 0. So we know the starting index of k. Now to understand the behavior of k, we need to understand what we actually are trying to do here. So in this case, we are trying to remove any value that is occurring twice in the array. And how would we take care of that? Now, if this was an array of any order, in that case, we'll have to maintain some kind of a map or some kind of a set where we store what kind of values have we already seen inside of our array when we are traversing it. But in this case, it's a sorted array. So what that provides us is that if any element in the array is occurring twice, that means that element has its equal element in its neighborhood itself. The element cannot be anywhere away from it. It must be in its immediate vicinity. So by following that concept, what we need to understand is that if we want to check that an element is occurring more than twice, we can just check if it is equal to its previous element or not. And to do that, we can just maintain another variable, which will call our previous element. And that needs to update to one of our array. So basically, this element needs to lag our array by a value of 1. So it should be 1 behind our array. So somewhere around here. And what should be the initial value? The initial value can be anything that's out of bound of the values that can be put inside of our array, or it can be none if nothing is given to us, or something like that, so that we can check if it is none and we just don't compare it at that point. But for our problem or for any problem, it can also be any value that we are pretty sure is never going to be inside of our array. So it's out of bounds. And basically, whenever we come across a value, if it is not equal to our previous, we put that value inside of our k index in the final in the nums array. And if that value is equal to its previous value, which will happen in the second case, we don't want to do anything. We don't want to increment our k pointer, and we don't want to put that value anywhere, because this value should trash out as this is occurring twice. So I hope that makes sense. And if you have seen the previous video, what we are essentially doing is, instead of having a well that has been predefined for us, we are having a well which is gonna be updated as we move through the value. So the val is just dynamic. So I think watching the previous video actually helps a lot in this condition. And as we can see that our nums I will be in the range of minus 100 and 100. So from this we can clearly infer that our previous can instantiate to minus 101, because our values can never be equal to that. And sorry for the semicolon, it needs to be a Walrus operator. And other than that, let's not have it capitalized. No, it's not a constant, and it makes sense that a constant is capitalized. It doesn't for a simple variable. And other than that, our k should instantiate to 0. And yeah, we just need to iterate our I and update the values using the k helper variable. So I think there is nothing much more new about this problem, and it goes to show how you can use the problems that you have solved already and use the constructs you have made in them to actually make DSA easier for you. Because in this case, we exactly use the concept we have learned in remove elements, and if you had seen that video, this problem would have been a piece of cake for you, because you already have built the concept for it. It's very similar to how you learn characters, then you learn words, then you learn sentences. It's exactly the same thing as it. That's what we are trying. That's why we are trying to do these problems. But okay, enough of that. So we have defined our previous, we have defined our k. Now we are going to define a loop which is going to traverse through our array, and to do that, we are just going to instantiate it at 0, and then we are going to make sure it is always less than our nums, and finally we are going to have it increment. Yeah, if only I can type today. I don't know what's happening to my typing today. And then finally we just check if our nums I is equal to previous. Well, not equal to previous, similar to how we did in the previous problem, where we need to do something if it is not equal to previous. If it is equal to previous, we don't do anything to our k pointer, or we don't update any values. So it's better to write a condition for not equal. And in this case, we are just going to update our nums helper. Let's call k helper again, just to maintain the naming that we are doing in the series. And your helper helper pointer is going to be updated to your nums I if it is not equal to anything, and you're going to increment your helper. And at the same time, whether your nums is equal to your previous or not equal to your previous, you're going to update your previous with your nums I, so that in the next iteration, your nums I is leading by 1 for the previous element. These lead and lag, I hope you understand the lead versus lag kind of things that we use in signals and stuff. But yeah, basically it should be 1 off of your nums I. So basically, when we go in the next iteration, your previous is going to point at nums I minus 1 for that iteration. And finally, we are just going to return our helper, and again, not repeating the mistake from the previous video. And let's just run this. I think that should be it. It's a pretty small video. It follows on the concepts of the previous problem, and I hope it makes sense to you. Yeah, there you go. So it's accepted for both of the cases. That's amazing. This is our case, and let's just finally submit it. Drum rolls, guys, drum rolls. Boom. Okay, another one in the bag. So we again beat 100% in runtime. So I think the problem is optimized. And also we beat 26.64% in memory. Well, that's not the best. Instead of defining a previous variable, if we just want to have something that is lagging to our array by 1, we can just start our iterations at I is equal to 1. And in that sense, we are pretty sure that the first element of the nums should always be there. And we'll start at 1 and we'll check if it is not equal to nums I minus 1. So that is another way of doing it, and we don't need to update any previous operator because that is maintained by our I minus 1. And in that case, we are not using an additional variable, so our memory utilization should actually be less. It's still constant memory, but it should be somewhat less. Oh shit, we get a wrong answer now. Wow. Why would that happen? Because our helper should also have instantiated that one. I'm stupid. Sorry for that. Because now that we are iterating, now that we are completely ignoring the first value, we were not instantiating our variable at 1, which it should have been. We were instantiating at 0 again. And the problem was that our override started from here, where it should have started from here, because we are saying the first element never needs to be touched, because it's always going to be unique in a sorted array. So let's go back here. Let's run this again. Yeah, now it's accepted. So cool. Now let's submit and see if the memory we actually get better at it or not. Yeah, somewhat better. I don't trust these LeetCode memory and runtime beats thing, but hey, it is better and that's what matters to us. So cool. I hope you enjoyed the video. See you next time. Bye bye.